When mammoths rose from chaos, the brutal Cenozoic that built the Ice Age giants, everything you think you know about what happened after the dinosaurs is wrong. Not partly wrong, fundamentally, completely wrong. Because here is the secret I will reveal to you before this video ends. The world that emerged in the Cenozoic did not become safer, more orderly, or more predictable. It became exponentially more vicious. The creatures that would eventually evolve into mammoths and saber-tooth cats inherited a planet locked in constant evolutionary warfare, and that brutal inheritance shaped every cell in their bodies. If you have ever wondered why the giant ground sloths fought each other with such ferocity, or why mammoths lived in herds structured like military units, this video is for you. I would ask you to subscribe and stick around because each week on this channel we pull back the curtain on the animal stories that textbooks ignore. Also, drop a comment below telling me which Ice Age creature terrifies you most. I read every single one and I want to hear your take. Wait, this part matters more than you might think. Before we go deeper into the mechanisms that built these titans, I need to tell you that the complete guide to the evolutionary pressures that shaped Pleistocene megafauna has been laid out in our in-depth ebook, available in the description and pinned in the top comment. That guide walks through the specific environmental signals that triggered the physical transformations we will discuss, and frankly, it is essential reading if you want to understand not just the what, but the why. The moment the asteroid struck was not the beginning of the Cenozoic. That distinction matters. The Cenozoic epoch officially began 66 million years ago, but the transformation that would eventually produce mammoths took another 40 million years to properly accelerate. Those first few million years were a bottleneck of survival, not expansion. The planet was fundamentally hostile. Temperatures swung wildly. Acid rain fell from skies choked with sulfur and carbon. Photosynthesis ground to a near halt across vast continents. What emerged from this chaos were not the creatures we might expect. Early mammals that survived were small, desperate, clinging to whatever ecological niches remained. But something profound was happening beneath the surface. Natural selection was running at overdrive, operating under conditions so extreme that only the most adaptive genotypes could persist. Species that ordinarily would take millions of years to develop new traits were now compressed into hundreds of thousands. Evolution was not just speeding up, it was transforming. By 56 million years ago, something shifted. The Paleocene-Eocene thermal maximum, or PETM as we call it, sent global temperatures soaring. Vegetation exploded across the landscape. What had been barren wastelands transformed into dense subtropical forests in North America and Europe. Vast swamps appeared, new niches opened, and mammals, finally, began to grow. This is where the inheritance I mentioned becomes critical. The mammals that expanded during this period were not evolving in a vacuum. They were competing in an environment that had been fundamentally shaped by 10 million years of extreme selection pressure. Their ancestors had survived the unsurvivable. That genetic stock carried something distinct. Call it resilience. Call it metabolic efficiency. Call it the raw architectural blueprint for surviving scarcity and violence. Whatever name we give it, that inheritance was encoded into their DNA. The early proboscideans, the ancestors of mammoths, first appeared around 55 million years ago. They were not the giants we know. Early mastodons were perhaps the size of a modern fox, but they possessed something crucial, the genetic scaffolding for rapid size increase. Their teeth showed signs of adaptation. Their skeletal structure indicated metabolic patterns that would eventually support animals weighing 12 tons. Why does this matter? Because those early adaptations were not random. They were direct responses to the ecological pressures that had been sorting mammals relentlessly for millions of years. The creatures that survived had already been pre-filtered through an evolutionary gauntlet so brutal that weakness was not an option. By the time mammoths reached their full massive form, 30 million years later, they were not simply large versions of earlier species, they were the hyper-specialized products of a long chain of selection events that had eliminated every weaker alternative. The same pattern holds for every megafauna species that would eventually dominate North America. Saber-tooth cats did not evolve their legendary fangs because they were flashy or impressive. Those teeth evolved because the herbivores they hunted had already been through the same selective crucible. Early ground sloths developed their incredible strength not as a luxury but as a direct requirement for surviving in an environment where competition for resources was constant and often lethal. What I am describing is not the familiar story of gentle evolutionary adaptation. This is the story of an entire lineage that was born from chaos and never truly escaped it. Every species that would eventually become part of the Pleistocene megafauna carried within their physiology a memory, quite literally, of the brutality that created them. That is the inheritance. That is the secret that shapes everything that follows. The Cenozoic Era did not unfold as a steady climb toward perfection. Instead, it resembled a jagged mountain range of environmental crisis after environmental crisis, each one narrowing the survival window for entire groups of animals. Between the KPG extinction 66 million years ago and the rise of the true ice ages roughly 2.6 million years ago, North America experienced what paleontologists call the Eocene-Oligocene transition. This was not a gentle climate shift. Temperatures plummeted over just a few 100,000 years. Rainforests contracted into grasslands. The world became colder, drier, more unpredictable. Species that had thrived in warm, humid forests suddenly found themselves in ecosystems they no longer recognized. Many vanished. Others transformed. Natural selection operated with ruthless efficiency, favoring animals that could tolerate extreme cold, that could survive on sparse vegetation, that could endure months without reliable food. The animals that survived these transitions carried forward a genetic and behavioral toolkit built specifically for survival under duress. This is where the story gets specific to North America. Roughly 25 million years ago, North America's climate had shifted decisively. Grasslands now dominated where forests once stood. The landscape resembled something between modern-day Mongolia and the Great Plains. Endless horizons with scattered shrubs and hardy vegetation adapted to cold and dryness. Herbivores that had evolved in forests now had to adapt to this open terrain. They grew larger to process more vegetation. They developed stronger jaw muscles and specialized teeth designed to grind tough grasses. Their legs lengthened, their vision sharpened. Everything about their bodies reflected the demands of the grassland ecosystem. Predators tracking these herbivores followed the same evolutionary trajectory. Cats with elongated canines began appearing in the fossil record around 20 million years ago. Early dire wolves, distinct from true wolves, occupied ecological niches that required sustained power and cooperation. Ground sloths, those massive terrestrial relatives of modern tree sloths, grew to the size of elephants. None of these changes happened overnight. They accumulated across hundreds of thousands of generations, each small shift in physiology or behavior conferring a slight survival advantage. Then came the Pliocene epoch, between 5.3 and 2.6 million years ago. The climate grew colder still. Antarctic ice sheets expanded. Northern hemisphere ice became seasonal and then permanent. By 2.6 million years ago, the first true glacial cycles had begun. These were not gradual cooling trends. They were massive swings between glacial and interglacial periods, each cycle lasting roughly 40,000 to 100.000 years. During glacial maxima, ice sheets a mile thick covered Canada and pushed deep into what is now the northern United States. Temperatures in North America could drop 15 to 20 degrees Celsius below modern averages. Boreal forests replaced grasslands in some regions. In others, Tundra and steppe dominated. The megafauna we know from the late Pleistocene did not simply appear fully formed. They were the product of millions of years of incremental adaptation to increasingly harsh conditions. Every species alive 20,000 years ago, when mammoths roamed across the continent and saber-tooth cats hunted in the tar pits of Los Angeles, represented a survival strategy that had been refined across millions of years of evolutionary pressure. Hold on, I need to make sure you understand the mechanics behind this. The reason these animals became so massive, so specialized, so seemingly overbuilt for their environments is not actually mysterious once you recognize the pattern. Life responds to extremity with adaptation, and the deeper we dig into the fossil record, the clearer it becomes that this entire lineage, this entire assemblage of Ice Age giants, was shaped by conditions we can barely comprehend today. If you want to understand exactly how this process worked, the specific biological switches that triggered size increases, the social behaviors that emerged under resource scarcity, the way predator and prey populations drove each other toward specialization, I have compiled the complete mechanisms in my ebook guide available in the description and pinned in the top comment. That guide walks through every major transition and explains the actual tools these animals developed to survive. Woolly mammoths did not evolve their thick coats as a whimsical choice. By 2 million years ago, mammoths were already adapted to cold climates, with shorter ears than their tropical relatives, thicker skin, and dense fur. But the further back you trace their lineage, the more you see this pattern repeating. Each ancestor was slightly better insulated than the one before. Each generation that survived the winters passed along genes for heavier coats. By the time the late Pleistocene glaciations reached their full intensity, mammoths had become mobile furnaces. They could maintain core body temperature in conditions that would kill most mammals within hours. Mastodons followed a different strategy. Less insulated than mammoths, they were browsers rather than grazers, feeding on shrubs and low trees in forested ecosystems that persisted even during glacial periods. Their massive bodies and elongated tusks served dual purposes: dominance displays within herds and the ability to strip bark from trees and access food sources other herbivores could not reach. Ground sloths, those colossal terrestrial creatures, grew to weights exceeding 5,000 kilograms. Their size alone granted them thermal inertia. A warm-blooded giant cools more slowly than a small animal, an advantage when resources are scarce, and thermoregulation requires constant energy expenditure. These were not random variations. They were coordinated suites of adaptations, each reinforcing the others, each reflecting millions of years of selection pressure toward survival in an increasingly unforgiving world. But there is something almost unsettling about these adaptations when you examine them closely. They were not merely responses to cold. They were preparations for scarcity itself. The northern Ice Age ecosystems had become extraordinarily patchy and unpredictable. A mammoth might migrate 300 kilometers in a single season, following vegetation that bloomed and died according to rhythms shaped by orbital cycles and atmospheric composition. Food sources that sustained a population one year could vanish the next. Saber-tooth cats understood this instability intimately. Their entire predatory strategy evolved around reliability. Unlike modern lions or wolves that pursue prey across open terrain, saber-tooths became ambush specialists in broken, forested country where visibility was limited and approach distances minimal. Those elongated canines, sometimes measuring 28 centimeters, were not designed to cut throats or severe spinal cords like modern feline teeth. They were designed to pierce the soft palate, the throat, and the vital organs of struggling prey in close quarters. A saber-tooth's kill was brutal and quick, a necessity when every encounter risked serious injury from thrashing hooves or desperate tusks. Dire wolves hunted differently. Larger and more robust than their gray wolf descendants, dire wolves reached 80 kilograms on average, nearly 20% heavier than the largest modern wolves. That mass carried a cost. They were slower, less agile. Their advantage lay in coordinated pack ambush, bone-crushing bite force, and the ability to overwhelm prey through sheer collective strength and endurance. Archaeological evidence from the La Brea tar pits in California, a geological trap that preserved remains of hundreds of dire wolves and their prey, reveals kill patterns consistent with organized group hunting of immobilized or weakened prey. Hold on, before we push forward, I need you to grasp something crucial here. The mechanics of survival during this era were unlike anything you might read in a typical natural history text. These were not simple predator-prey relationships playing out year after year in stable patterns. This was a system under constant pressure, and I mean constant. The deeper mechanics, the actual environmental triggers that cascaded through these ecosystems, the feedback loops that either stabilized or destabilized populations, the signals that animal bodies actually read from their surroundings, those are explained comprehensively in our complete reference guide, available through the link in the description or pinned in the comments. It is a paid resource, but it covers the actual mechanisms behind climate-driven ecosystem collapse in ways a single video cannot reach. Climate instability made reproduction itself precarious. Female mammoths had extended pregnancies, around 22 months, and their calves required 4 to 6 years before reaching metabolic independence. A mother could only afford to breed every 4 to 5 years, miss a breeding window because food scarcity occurred at the wrong moment in the cycle, and an entire generation vanished. Saber-tooths faced similar constraints. Their litters were small, development was slow, and juvenile mortality from failed hunts or separation from the mother was catastrophic. Ground sloths displayed even longer generational timescales. Their massive bodies required enormous caloric intake, their metabolism sluggish compared to more active mammals. A pregnant female ground sloth could not afford to deplete her fat reserves during the final months of pregnancy. Miscarriage and maternal death were consequences of poor seasonal timing. These creatures were locked into rhythms they could not alter. Their bodies were calibrated to environmental patterns that had held stable for hundreds of thousands of years. They migrated when internal hormonal signals told them to. They bred when photoperiod and temperature aligned. They accumulated fat reserves when food was abundant, burned those reserves when food was scarce. Then something shifted. The cycles that had governed their existence began to stutter and fracture. Seasonal amplitude increased. Droughts lasted longer. Vegetation patterns changed not gradually but sometimes within a single generation. For animals whose entire reproductive strategy depended on predictability, this was a crisis without a name. Natural selection had never equipped them to handle this. Selection pressure works on timescales measured in generations. Evolution responds to patterns that repeat. When the pattern breaks, when the environment becomes chaotic rather than merely harsh, adaptation reaches its limits. The very traits that made these animals supremely successful during stable Ice Age conditions, their size, their specialized diets, their long development periods, their dependence on predictable migrations, became vulnerabilities. This is the paradox that few consider. The Pleistocene giants did not fall to simple predation or straightforward starvation. They fell because the world they had evolved to master was transforming faster than their bodies could respond. By 15,000 years ago, North America's climate had entered what we call the terminal Pleistocene, a period of violent fluctuation that would define the final chapter of the megafauna. But this wasn't a simple cooling or warming. It was more like a broken record, skipping backward and forward unpredictably. Temperatures would spike upward for decades, then plummet again. Rainfall patterns inverted from region to region. The Great Plains experienced intervals of torrential moisture followed by crushing aridity, sometimes separated by only a few human generations. A mammoth herd that relied on tundra grasslands in one century might face semi-desert conditions in the next. Their migration routes, passed down through social memory across thousands of years, no longer led to reliable forage. Ground sloths that had thrived on stable browsing patterns found their preferred plants vanishing or blooming at the wrong times. A megatherium, a creature weighing as much as an elephant, could not simply adjust its appetite or change its route with the nimbleness of a smaller herbivore. It was committed to size, committed to its feeding strategy, committed to a world that was ceasing to exist. The energy demands of these massive bodies meant every miscalculation in food availability carried immediate, lethal consequences. There was no buffer, no margin for error. What made this period uniquely catastrophic was that humans arrived precisely when this environmental chaos peaked. Archaeological evidence places the first widespread human presence in North America around 15,000 to 14,000 years ago, though some sites suggest earlier arrivals. These were not casual visitors. They were skilled predators who had spent generations adapting their hunting techniques to target large prey. They understood megafauna behavior. They knew how to coordinate in groups to bring down animals 10 times their own mass, and they were multiplying across the continent at a time when the megafauna populations were already fractured and stressed by environmental upheaval. This is where I need to be precise about something. Before we continue, hold this thought carefully, because what I'm about to explain is the centerpiece of why these giants truly vanished, and it requires you to see the full architecture of cause and effect. Our complete guide to the extinction of North American megafauna, available in the description and the pinned comment at the top, walks through the ecological mechanisms and the evidence in exhaustive detail. That resource lays out all the signals that paleontologists use to distinguish between climate-driven extinction and human-mediated collapse. It's worth the investment if you want to understand not just the story, but the science underneath it. For now, though, grasp this. The giants were not killed by either climate or humans acting alone. They were crushed between them. Consider the mathematics of it. A mammoth consumes roughly 180 kilograms of vegetation daily. An adult male needs to reach that caloric threshold or it begins losing condition. In a stable climate, a herd could predict where that food would be. Migration routes were reliable, but in the terminal Pleistocene, that predictability shattered. Droughts could reduce available forage by 40 or 50% in a region. Climate oscillations meant a mammoth herd might find itself in a landscape that had transformed entirely in just 3 or 4 seasons. Simultaneously, human hunting pressure intensified. Archaeological sites show increasing concentrations of mammoth and mastodon bones at kill sites, particularly in the Great Plains and along river valleys where prey animals were forced to congregate during dry periods. The animals couldn't run faster. They couldn't evolve thicker skin or smaller appetites in time. They couldn't change their reproductive biology to produce offspring that matured in half the time. Evolution is powerful, but it works on timescales that now seemed geological while the crisis unfolded in mere centuries. Dire wolves faced a different but equally fatal squeeze. Their entire ecosystem was collapsing from the bottom up. As herbivore populations crashed under combined climate stress and human predation, the large predators found their food sources drying up. A dire wolf pack that once could rely on consistent encounters with horses, bison, and camels now faced weeks of fruitless hunting. Smaller predators, coyotes, foxes, mountain lions, could survive on rabbits and rodents. Dire wolves could not. Their massive jaws and bone-crushing bite were engineered for megafauna. Everything else was starvation. Saber-tooth cats experienced something grimmer still. As their preferred megafauna prey disappeared, competition intensified for what remained. Multiple predator species were now hunting the same shrinking pool of animals. The Pleistocene cats were adapted for explosive power and precision strikes at close range, not for persistence hunting across barren terrain. They required consistent access to large prey. Without it, populations fractured, territories overlapped, conflict between predators increased, starvation followed. By 12,000 years ago, saber-tooths had vanished from North America entirely. The last populations clung to isolated refugia in South America, where megafauna lingered longer and prey remained marginally more abundant. Even those final holdouts would be gone within another 1,000 years. The ground sloths faced a different catastrophe altogether. These creatures were built for stability, not speed. A giant ground sloth weighed up to 4 tons. Moving required tremendous energy expenditure. They were adapted to consume the vegetation of a world that no longer existed. As grasslands expanded and woody plants retreated northward, the sloths found themselves in ecosystems increasingly hostile to their survival. They could not migrate quickly enough to follow their food sources. They could not adapt their digestive systems to new plant matter in time. They were prisoners of their own biology. The mammoths endured longer than most. These were the true survivors of the Pleistocene, equipped with thick insulation, efficient metabolisms, and the ability to digest a wider range of plant material than their contemporaries. Yet even mammoths could not escape the mathematics of a collapsing ecosystem. Herds that once numbered in the thousands fragmented into smaller groups. Breeding populations fell below sustainable levels. Genetic diversity plummeted. The isolation that saved some populations during earlier climate cycles now sealed their fate. Cut off from other herds by expanding forests and changing topography, small populations spiraled toward extinction through inbreeding and demographic collapse. Before we continue, I need you to hold on to something critical for the next section. The mechanisms driving these extinctions, the exact chain of ecological failures, the timeline, the role of climate versus human predation. These are explained in exhaustive detail in our complete guide to Pleistocene collapse, available in the description and pinned in the top comment. That resource breaks down the evidence layer by layer, the debates among paleontologists, the fossil record itself. It's a paid guide, but it's where the real depth lives. What happened between 13,000 and 10,000 years ago was not a single extinction event. It was a cascading series of failures that accumulated into species collapse. Temperature fluctuations that climate models can now track to within a century show rapid warming periods, sudden cold snaps, and climatic instability that would have devastated populations already stressed by food scarcity. Human hunting pressure, which intensified as people spread throughout North America during this same window, contributed significantly, though the degree remains contested among researchers. Early evidence from kill sites in the American Southwest shows that people were actively hunting mammoth, bison, and ground sloths. The Ansic child, whose genetic material was recovered from Montana and dated to 12,600 years ago, belonged to a population that had been in North America for perhaps only a few centuries, yet already the megafauna around them were in severe decline. The question that paleontologists still debate is not whether humans hunted megafauna. They did. The question is whether human predation was the primary driver of extinction, or whether it delivered the final blow to populations already weakened by ecological collapse. The evidence leans toward the latter interpretation, though reasonable scientists disagree. Mastodons, those strange relatives of mammoths with different teeth and different dietary preferences, followed a similar trajectory. They were adapted to browse on trees and shrubs, a diet that made sense in the mixed forests of the interglacial periods. As climate shifted and forests fragmented, mastodons found themselves in landscapes where their preferred food was scarcer than it had been in thousands of years. Their populations, which had been stable for millennia, began to contract rapidly after 13,000 years ago. The last mastodons persisted until roughly 10,000 years before the present, making them among the last megafauna to vanish from North America. Across this entire 3.00-year window of decline and extinction, the pattern remained consistent. Megafauna that required specific, abundant food sources disappeared first. Generalists lasted longer. Creatures with smaller body sizes had lower caloric requirements and could subsist on degraded ecosystems. The giants, for all their power and dominance, were the most vulnerable to the new reality. This is the secret I promised you at the beginning. The mammoths and mastodons and saber-tooth cats did not vanish because they were weak or poorly designed or lacking in intelligence. They rose from the chaos of the Cenozoic, dominated landscapes for millions of years, and ruled North America as absolute sovereigns during the Ice Age itself. Their extinction was not a failure of the creature, it was a triumph of transformation. The real story is this. The Cenozoic taught the mammoths how to survive in extremes, how to navigate climates that would have crushed weaker species, how to thrive across continents through unimaginable ice ages and warming cycles. That same brutal Cenozoic, the one that forged them into giants, locked them into a specific way of living, specialized bodies, enormous caloric appetites, long gestation periods, small family groups. All of these traits made sense when the Ice Age was a constant, predictable cycle that lasted 100,000 years at a time. The mammoths knew that food would be scarce, yes, but also that it would return in a pattern they could rely on. When the climate began to destabilize after 15,000 years ago, the pattern broke, not gradually, not predictably. The warming came in sharp pulses, followed by sudden cold snaps, followed by decades of unpredictable drought. The grasslands that had fed mammoth herds for millennia became fragmented. The open steppe vanished and forests crept in. The creatures that had been shaped by 66 million years of Cenozoic chaos discovered that they could not adapt fast enough to chaos of a different kind. The mammoths and mastodons needed thousands of years to evolve significant changes to their bodies, their teeth, their metabolic strategies. They did not have thousands of years, they had decades, perhaps a century or two at most. Their bodies were specialized weapons built for a specific war that had suddenly ended. And specialization, it turns out, is the price of dominance. The very traits that made them rulers of the Ice Age became their sentence. What the Cenozoic built, the Cenozoic could not save. The era that created giants through relentless selection, competition, and survival of the most specialized ended up destroying them through the very same mechanism: climate change, resource scarcity, the need to adapt or vanish. The mammoths rose from chaos. They conquered it, they dominated it, and in the end, they were undone not by weakness, but by their own perfection. They had become too perfectly adapted to a world that was transforming faster than evolution itself could respond. This is what the complete guide explores in depth: the specific genetic bottlenecks, the archaeological evidence of population collapse, the isotopic signatures in bone that reveal exactly what these creatures were eating in their final centuries. You can find it linked in the description and in the pinned comment at the top if you want to understand the deeper mechanisms behind these extinctions. The mammoths, the mastodons, the dire wolves and saber-tooth cats, they were not failures of nature. They were the Cenozoic's masterpiece. They rose from the chaos that killed the dinosaurs. They survived ice ages that would have obliterated lesser creatures. They built ecosystems, shaped continents, and ruled with a presence so profound that their absence still echoes through the fossil record. And then they were gone, not because they were inferior, but because they were perfect. Perfect for a world that no longer existed. Your challenge this week is simple. Find one moment to stand in a landscape, a forest, a grassland, a canyon, and imagine what it looked like when the giants walked there. Not as a fantasy, but as a historical fact. Those bones beneath your feet, those valley walls shaped by ice, those extinction timelines recorded in the rocks. The mammoths were real, they were here, and understanding why they vanished teaches us something about our own world, about specialization, about the fragility of dominance. Thank you for staying with me through the story of how mammoths rose from chaos and ruled an entire era. If this video resonated with you, please subscribe so you never miss an episode. We upload new deep dives into Ice Age giants every single week. Leave a comment below and tell me which megafauna fascinates you most, and hit the notification bell so you're the first to know when the next Titan awakens on this channel.